And hello. Just a moment, I'll be getting started here. Alrighty, okay, let's start this with a little more enthusiasm. And hello! Or something. Ooh. Okay, there we go. Yeah, so I guess let's get start off right away with updates, of course, as we usually do. Oh, okay. Just making sure the chat was working, that I could see it. It looks like all's good. All right. So, outline as usual. We've been working on things, and not much really has been added to this. Nothing actually got added to this, I think, overall. Because I have been more immediately R&Ding, specifically shader stuff. And last week, we were looking at different engines and what to choose. I looked at Unity 6 to see what it could do, and then within Unity 6 there's different rendering pipelines. We looked into and by the way, yeah, looked into Unreal Engine and Godot, as well as a Unity engine. Godot had the same, all three of them actually, except HDRP, which has something called camera space rendering. All three of those had the same problem that I want to avoid as much as possible. And I honestly, the first thing after that week, the first thing I found was a solution that can be applied to any Unity shader and not just HDRP, not using the whatever camera space rendering. It's kind of the same thing, but yeah, it probably has the same caveats in the end. So if we were to look at the camera rig here now, we have our two characters, of course, in here, with the camera pointed right at them. And so now if we move to 10, you see them move, right? And move to 100, you start to see the one on the right doing strange things already at 100, then 1,000, and it's already getting weirder. Then 10,000, and we can start to see a little degrade, and then 100,000, the degrade is very noticeable, and 1 million, it's now a mess. But yeah, it was the one on the left. I figured out a means of basically making sure that the coordinates for the vertices stay within constraints that are usable by the shader. And this trick was done. It was actually simpler because apparently I wasn't the first person to run into this, of course. This is why we researched, this is why I also asked around and talked around to people. Found out another particular person who I know ran into this not even about like a month or two ago. They were already dealing with this problem and trying to find a solution. And they did, but I probably took it maybe a step further. I had originally done what I noticed essentially is that the problem was in Unity object to clip space. Unity object to clip space basically had a really big number and a really small number, and when you work with a really big number and a really small number in floating point, that's how you start to get floating point precision error. So what we both noticed, the individual that found this out too, as well as myself, is that it's an order of operations problem. And the order of operations that Unity does it in is what causes this mess of polygonal problems. But it's a trade-off. Because we're moving the order of operations around, there's still some FPE that will happen, or FPPE. And as you see when I move the camera, my shader is shaken about. That's because the base coordinate, the center of the object, is still receiving floating point precision problems. But, I'd rather it shake like this than look like it does on the right and shake. So, yeah, either, there's only gain from this, essentially. So looking at, what we did, basically, I ended up writing a method that I apply to my old shader. So you can actually go look at my old shader for Unity for VR chat stuff, and you can see the code in there if you want to review it. There is a link that's been dropped in the subscribers channel. So the subscribers, you can just go there and you can find the link and whatever. You can also find any resources that I've been coming across for specifically working with URP shaders, because URP shaders apparently don't have any documentation whatsoever. It's chaos. It's annoying. But yeah, so let's take a look at that method. Should be in shared. Right? Oh, object to clip pose. So I wrote my own object to clip pose. It's actually quite simple in the end of if MVP exists. If MVP exists, which is already a pre-calculated, basically it's the camera space. It's the model view to projection. It's already taking the world space and computing it with the clip space first. It does that ahead of time, which basically the math for MVP ends up looking like this. It's not quite a normal, and this is simplified down because what I first did is I expanded the multiplication method, the linear algebra multiply for matrices method. I expanded that out, and then I did the pre-compute, all by hand, and then came back and simplified it down to this. So this is where we have literally the world, Unity object to world matrix, and the view point matrix, so Unity matrix VP, and that's where it's MVP because it's world and model and viewpoint. So we have to basically kind of inverse multiply it, and I'm not sure if there's something that is a shorthand for this, but instead of like going row to down column to multiply it normally, we have to do it the other way around, where we're taking a like this is a row, so we're going down the column. Yeah, okay, this is going down the column of M or W, object world, and it's going across or down the row of VP. And this is always like an inverse multiplication. I don't know if there's like a way of there's a method that already just does this. But it's simply, you take that MVP, you calculate that MVP instead. It's supposed to be expensive to compute this, but not really. Come on, it's just a bunch of multiplication. And you're going to do this anyways by doing mul, the mul method, anyways. So it's just better to do it this way. Then you get easier to work with numbers. And I'm starting to realize maybe I goofed, because why is it dot when you look at this? Because, it's... I know there's a reason for it, but something seems... Because this is supposed to represent a float 4, I think, in the end, and this is also supposed to represent a float 4. Oh yeah, because yeah, 0, 1, 2, 3. This is a flow for, and likewise. So yeah, it's just doing a bunch of multiplication to bring these all together into a matrix. And so you compute MVP, and then you just multiply that by the object space of the of your position, and then voila, you have this fix. And in most cases, matrix MVP already exists, so you don't have to, like, it's already saving time and not doing this bit. But in the case that it doesn't, then of course we have to calculate it, and I've already tested this to make sure by removing it. Like, we can even come in here and just do this. The problem also is because that hash. There we go. Let's redo that, and there we go. And then we get, the same thing. You can see that, yeah, that math works to calculate MVP. But voila. Yeah. So with that done, I also did further research into URP and HDRP. I still don't like HDRP. I really, really hate it. The code base for it is a mess. The code behind it is messy. The setup for it is messy. It's just too much. And I think that's where Unity did something right with URP. And it's still the SRP, which is another acronym. I know, scriptable render pipeline. Both of them are scriptable render pipelines. Where URP is universal render pipeline and HDRP is high definition render pipeline. So URP is a little bit more complicated than standard, but with a good reason, I think. But also, with what I discovered with URP is actually easier. And it has been easier to write a shader with URP, and at least I am able to implement features better under URP, as we can see so far. So I wanted to discuss that a little bit too here, what's going on. So we have, our two shaders here. The one on the right is the URP standard shader, essentially. It's not standard shader. Like, if we switch between that and this, or standard shader in this, we can see that difference. So here's, URP lit. Let's get the material here. So get these materials selected. We got URP lit. And standard still does exist, but it's under the standard render pipeline. And looks like it actually doesn't even want to render. So maybe I can't show you the difference. But it is not as good. Somehow, the standard shader, the standard shader for URP, does look better than the old standard shader, of course, because they wrote this URP thing to make things better. But what I ended up writing is, and URP, and this particular one is doing standard with deferred lighting. So that's one thing that's actually something different here. This is, not the normal Unity render pipeline that most people are familiar with shaders, which is, forward. Where forward is messy in its own way, and a lot of people wonder why they even went forward in the first place. But forward rendering basically starts with a base pass, and the base pass renders basically like a specific the base color with a specific set of features that are only available to the base pass. That includes reflections and things like that. It's basically everything but pixel lights. And then pixel lights actually get passed into the forward pass. So each forward pass then adds to the pixel light, or adds to the color that already exists. And, you have to kind of do this funky dance between the base pass and the forward pass to get things looking the way you want to. Deferred is actually more complicated than that by default, so it's kind of funny in that way. But deferred offers other features though that forward doesn't, and deferred ends up actually offers you a base geometry pass where it's just calculating depth and calculating the actual geometric stuff, and then there's the G buffers following that render for each light. However, both processes now have a new pass that's allocated to them called forward add only. Why is it called forward add only? I don't know. Does it cause confusion? It sure the hell does. But it's a brand new type of pass that basically will allow you to do all the lighting, literally all the lighting, every last little bit of lighting, and every other like major type of calculation in one pass. This makes a fatter shader, of course. It makes it more monolithic, unfortunately. But when we're dealing with a cell shading system, we need it to be monolithic. We need access to all the lights. And with that, that's how we can access all the lights, including shadows and the shadow attenuation and everything like that. And this is something I've been working on all week to write. We can get one solid final shade over the geometry, and also do even fancier calculations for lighting, so we get nicer looking, more ambient lighting for a cell shader. So this gives us a more warm and animation feel to our colors, and it allows us to actually create animation effects within the shader itself. So now we get the really fancy gradients and coloring without losing the original base color and base art, and at the same time adding our shadows on top of it. And of course, this being with everything added into it means if I kill this point light, now we can see the lighting of the world going on. Or if I add just the point light and if we remove the moonlight in this case, we get the same deal where it's a nice added shadow. And then of course all of it gone, then we get just the the little ambient light here, which is why it's kind of purple. So we can get nice little animation effects like this, nice coloring from our environment, so it becomes more environment aware. And there's actually something even more fancy going on here too to explain to you. And the newest version, Unity 6 and URP introduced this little guy, which is called adaptive probe rendering or probe volumes. So I didn't have to set a bunch of light probes anywhere just to get probe coloring. It adaptively puts probes where they're needed for animation and things. So there's like maybe 3 probes, and I'm only taking an assumption how it worked, but this is how I would have done it. Essentially, is that there's only 3 probes that surround your probe receiver that are constantly sampling its surrounding. I don't really know. I could be wrong on that, but whatever they're doing, the black magic that they're doing is great because I can now have this rich dynamic lighting that's all baked, by the way. What we're looking at is baked lighting. And I can have the player literally come up to a light that's baked and still get the nice, pretty, cell shading that we were getting, within a baked condition. And now that it's deferred with Forward Plus, I can add in that moonlight again, and you see it becomes part of that model. And we can even like scale this to see how that plays with it. Oddly enough, intensity is not getting added in there. That may be something I need to look into getting working functioning wise, because this should be affecting the attenuation there, and it doesn't look like it's actually being equated into the attenuation, which might actually be, and we might have a fix for this already. See, it's the main light usually. So let's look at main light. Main light's not always available because main light in this literally means the main directional light. Any additional directional light actually gets treated as a pixel light in the way Unity does its lighting model, which is nice and makes sense. So that's fine. So let's look at that main light. Set lighting. Get additional lights. Get main light. Okay. So main light. We might actually have to do in here light dot distance attenuation times light dot color dot W, like that. Or is it alpha? What is this? Okay, I left a note somewhere what this light has in it. Okay, it's color with 3. So this should have been calculated actually. It should have been added into the distance attenuation. So that might be a glitch in their, in their code. Because, yeah, intensity goes, oh, see, it does it there. If I go to 2 on that, you see it getting pulled back. But yeah, once it gets below a certain threshold, it just vanishes. And it appears to actually be like something insanely low. It's almost as if it's always an intensity of 1. So I might need to look into that. I'll leave a note here. The light intensity does not seem to be actually getting added unless to the shader, or to the light the light in the shader. So yeah, 0.01 and then off on. Well, see, it's not affecting the actual lighting of the colors. It's just affecting the shadow somehow. The shadow there is getting a little more intense than it should be there. Like as if my attenuation stack... Oh, ho 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 ho. Distance attenuation there is... Right, okay. This is intentional. I just realized, right. What I had decided to do for this and why that actually isn't getting affected, and I'm dumb, I should have seen this. I decided to keep a nice straight up cell shaded look at all conditions. I decided not to take in consideration for the actual shading part of it, that shade on it. I decided not to take in the intensity of the light for that shading value, just the directional intensity of that light. This is so, like, doesn't matter how intense or not intense the light is, that we can get a light that shade and no matter how much light there is. So, like, now if we pull the character away, whee, back there, and we get that red light again. There's our red light. Okay, and we come in. Right. So now you see this red light actually has varying intensity too. It's just based on the direction. And I did that aesthetically just so we can always have that nice cell shaded look no matter what the amount of lighting is in the scene. You know, because we're dealing with a, toon edge and everything. It just would make sense to have it look nice that way. So, and I've been trying to get rid of that word out of my vocabulary, toon. Everyone calls it a toon shader when it's a cell shader. I hate it. I hate the word toon. It makes it sound like it's, cartoony. It makes it sound that it's like meant to be a joke, a comedy, something slapsticky, not, taken serious. So that's why, things like animation and cell shading are words I'm trying to use in my vocabulary instead. And then, of course, this all comes down to that rotoscope look that we want. And you can see here, actually, there's outlines in the shader already that I've added, and what I call an inline to off-balance the outline, just to give it a nice, just enough outline look, to look nice, to look like it's, drawn. I'm going to put that back at 0.5, actually, and moonlight, and bring the player rig up. There we go. And, something I want to bring back, but I want to change the hacky way that I did it, is this shader up here, because right now it's kind of bound to a light, and it just kind of takes the first directional light in the scene, whether it's on or not. I'm not sure how that works or why that works, so that's what it's doing. And it handles the time of day based on that. And I want to refine this, the shader for this game. Make it look nicer. So, that's that. But yeah, that is just catching you up to speed of where I'm at and what I'm doing. That lighting model is done, and I think we need to take a note down before I forget to. So now, do we put this in the outline or not? Game engine or engine. Why can't I search? Control F. There it goes. Engine. No. Okay, tools research and development. Can we do RTX X? Will it actually be necessary? That's one thing I haven't. The answer is yes. The next question to that is. Next question. How? And do we? Okay, test engine's capabilities, camera shake issue, can Unity get around it? Yes. I've decided to go with Unity 6. Custom shader support, what can be done? Deferred. And this is Ford add only shaders. That greatly help with creating a rotoscope / cell shaded look. And we'll go into that a little more too as we figure it out. But this isn't design choices. So art, we need to go into art, I guess. Art style design. Okay, we'll add. Was decided to use Unity 6 for deferred forward add only rendering, so we can calculate all lighting in a singular pass and create a continuous cell shaded look while maintaining color gradients created by environmental lighting. And this is done by calculating all directional light into a scalar, which becomes which is used in the procedural calculation of the what you call it, the cell shading of the art. The light is calculated, well, the coloring is calculated by the done by calculating directional light into a scalar combined with the Unity shadow system, which is used for procedural, and then the coloring is calculated by the intensity of each light source with blending from base color to light color added with each light. So that's basically what's happening. I took and I played with different models to find out what looked nicest about this. But what basically is happening is that I am taking each light source, and then I'm taking the base color multiplied by the intensity of that light, and then lerping it with that end-dottle, the directional, lerping it between, the base color, that base combined color, and our light here. Whee! And voila. And I kind of lied there, so we need to make that actually happen. So we have that lerp here, and neutral color is what it's supposed to be called. Distance attenuation. Oh no, I didn't lie. There it is. Okay, so process color, which, oops, this is supposed to be base color. Yeah, that's supposed to be the base color. And this is also supposed to be the base color. Okay, and then by, distance attenuation, and then the other is by the light color itself too. But there's also the additional, cell range. And I think that's where maybe this is what's wrong is... we'll call that back color. Actually, a neutral color is a different thing here. That should be float A, we'll call it, is light.color.r plus light.color.g plus light.color.b, of course, over 3.0. And a neutral color is actually just A. And honestly, I think we can just do that, get rid of that bit, and then A. Ooh, what happened? And yeah, we can actually go back to calling this neutral color because that's what it is. Okay. Whee! Ah, there we go. Now we actually have something that looks a lot even cleaner. Wow! So we get a gray representation of the color. Which becomes, you know, the neutral color that it gradiates with, which becomes the, you know, the add color to the shader. So yeah, now we get better neutrals on that. You get some interesting effects here with this, and it's normal mapping. All right. Ah, this does get interesting at normals. Because now we get sharper color edges, which makes actually perfect sense because that's what it's going to do, and that's what we want. But it does look a little strange. But it could also just be because in our base texture and color, my bad, yeah, maybe the normals are a little too harsh. I don't know. It does seem like it should be like a 0.1 though. They're basically shades in the fold, or folds in the shade, or on the, yeah, outfit. But it is correct. Whatever. Yeah. So I don't. We're not really done with the summary here. So before I get diving into anything too deeply, I think we'll leave it at that. So we've updated our documentation with the design and what's happening with shader art and looks. But yeah, that is what we're going to be doing there to create that rotoscope look. That is how, and this is the results. Is this the prototype? Not yet. I'd say like getting this done and out of the way is a good start of planning and R&D, but I wouldn't consider this a prototype yet because, I mean, with a process like this, we're going to be constantly revisiting things and revisiting to tweak and fine tune it until we have a prototype. So I wouldn't really consider this a done deal. The coloring and everything yet. If somebody knows something that can, to improve it, I'd be happy to implement that and improve it beyond this. But yeah, I mean, otherwise, what do we got so far? Needed a drink of water. Yes, it's time to drink water. But anyways. And yeah, Guilty Gear Strive look. And I think, we're getting there. I think we're doing a little more, which is kind of what I hoped for though too. With this coloring, I think we are definitely getting more artistic and more environmental, which gives us that higher quality feel to it. I like this right here, the way it's looking. So yeah, other than that, other things that have been done in the process here, we looked at HDRP and it was not good. And then we found ways to bring back, that whatever. Um, and here, yeah, there's a bunch of shader coding and whatnot that we've been doing. And I've of course been pushing this. But also a little explanation of how we even got here with the shader. I've been picking apart the actual this shader because the source is like ready available to you, but also using those resources that we have in the that channel, the subscribers channel. And then of course, like some people have linked me stuff that have been helpful too, just to reaffirm some of my findings about the URP and how they kind of expect you to have that workflow. But they don't expect you to have that workflow because this other part of the problem is they expect you to do all this in shader graph. And oh no, I tried using, and that's another thing I wanted to talk about as part of the update. I tried using shader graph. For me, it slows me down like a lot. It just takes longer to find something instead of just typing it out. This like just rattles off the top of my head, and this kind of shader code, as you just saw me even just messing with the stuff and writing it, and this is just normal for me to know this kind of shader code. Doing it visually when I can just type it out takes more steps. Like my fingers going, typing out a word feels like one step in comparison of right-clicking just to open a menu. So it just felt laborious using it, but it also felt restrictive in ways that were not appropriate. Like the branching system was really odd, and it seemed to add more steps to the process of branching than it was necessary. Like I kind of get that they're maybe trying to calculate everything and not branch, but just lerp between the two, which is a mathematical operation. But you still have to saturate that value, which then becomes a branch. So it's zero sum at that point. Saturate is not a free command as much as everyone likes to think of it. There's still a branching operation involved in saturate. Let's verify that. Okay, what does... We can just ask ChatGPT. It should have something from somewhere, right? What does the code for HLSL saturate look like? So it does a min and then a max. So now we ask then, what does the code of min and max look like? And yeah, the code of min is a x is less than equal than or x. It's if x is less than y, then x else y, and that's branching. When you use saturate, you introduce two branches. So there's this weird paradigm and myth that they want to try to avoid branches, but they end up introducing branches, more branches, and then when trying to avoid them. So yeah, I get like they think that it's just more mathematical in its behavior, but I mean, if you use purely lerp between two methods, and sure, and you can do truncation to get 0 actually, if for a saturate, which is probably actually more closer to reality of what saturate is doing, but you can't truncate a 1. So that doesn't work. You still have to introduce branching to max to 1. All right, so knowing that and saying that, we have this, shader. And I mean, yeah, if you want to see, all compilers must be completed. Oh, okay, yeah. I was in the process of writing something. But yeah, let's go over what happened in the shader so far then, actually. So, in our exploration shader, here we go. Okay, you can see it pretty clearly. And let's go ahead and make it a little bigger for the camera. But it's pretty typical from here in the start, and this is to give a rundown about it. It's the general properties here. I am defining a custom shader editor. I'd like to show you it, but I don't know if it'll render right now. Let's see. Well, yeah, it is. There it is. Yeah. So it's the same. I'm using essentially the same rendering engine that I wrote for my shader because it just works. and honestly, URP kind of did something similar. It's just their boxes don't look as boxed as mine. Like, this is their little drop downs where, or mine here. Here's what my drop downs look like. They're doing something. Oh, they're not even remembering. Wait, are they remembering the state of those? Oh, yeah, they are. They're doing something to remember the state of those, and on mine it doesn't. Whatever. But they both have drop downs, ironically. It's just funny that they would do it that way. But yeah, rendering, base texture, color options, things like that are going in here. Yeah, so we introduce a color curving, which is basically grading. Oh wow, it's not really doing it very much on this. Unless we do all of it, and we can see it all at once with the color grading. Or color... Oh, excuse me. Oh my god, I can't believe I just did that on... That's embarrassing. But anyways, so our color options, right? Our color curving is basically a grading type that's going on. And why isn't it working? I don't know. Maybe because it's bright? It seems to actually be doing it. It's just... Yeah, actually after 1, it doesn't seem to be doing anything. Which is odd. But basically, it's a simple thing. It's literally a curve. It's changing the curve behavior. And let's take a look at it and see why maybe it's not doing the way it's supposed to. But I plan on implementing more than just color curving. I want to bring in all the features that I usually use. I take the absolute, and maybe that's actually what's breaking it, is the ABS. Bam. Right? Bam. No. Interesting. Maybe it's because the light colors are actually not affecting off the base color. And this should be working off the base color. Bingo! That should have been working off the base color. And yeah, it recommends us to do an ABS on this. Like their shader compiler balks at you saying, hey, this could be negative. So use ABS on it. So okay, fine. We put ABS on it. And yeah, we've been using a 1.3 color curve, which is basically just the color to the power of 1.3. This causes color grading. Essentially, it lowers as the numbers go up, the overall colors dampen, lower. The curve goes down, and creates more of a that ACES look. ACS is usually around a curve of 1.5 when they're 1.3 to 1.5. So basically, this is like implementing ACES in a pre-process manner where it should be, rather than post-process. I've always been against post-processing of color grading because it's like, why when it would look better if you do it at the shader. But yeah, and eventually this will also have hue, saturation, other things and like that in there. What the other thing that was implemented today, specifically, of course, was the texture color not the texture. Well, texture color, yeah, was implemented. But the normal mapping, which you already seen me mess around with, I did pick apart their thing to implement a URP version of, normal mapping, which I found something interesting in there actually that I wanted to go over about. Good thing I'm talking about it, and it's this. We get more floating point precision error for some reason, and I found out the reason for that was this. When you have color values that are normally byte-wise ordered, right? The way they calculate the floating point number is they take that byte number. So we have 255. That's basically typical RGB color channels. The neutral gray, the zero of no motion in your normal is 127, right? When your normal map has 127, that's what that means. It's there's no up or down motion because this would mean centered. That's actually why the normal maps are colored the way they are. Essentially, if we were to get Paint, MS Paint, let's draw this out, right? Let's go. Okay, so what we have, right, when we do normals normally, we'll just have a surface, well, let's back this up a bit. Let's have a surface like this, okay? We got some depth here, all right? Let's use a thicker brush. There we go, get a thicker brush so you can see better of what I'm drawing here. All right, so what we have is, say this direction is up, this direction is down. So up. Okay, let's not. Let's just say this is X. X positive, X minus, right? And this is Y. So Y positive, and this is Y negative. And I use X and Y, but what this really is U. Whoa, what is up with my tablet? Okay, so U, U, and V. All right. So what we have here, is U and V. Okay. But there's a third thing in the normal. So let's mark it here. Wow. The tablet is a little too sensitive. Maybe if I set it flat, there we go. So what we have here, okay, is red, green. Oh, there it goes. It's. I wonder if I can change the amount of distance I have to have for it to well, whatever. Okay, so red, green, and blue, right? This is our normals. So what red will control is essentially V plus or minus. Green controls U. Well, wait. We're already wrong. My bad. This controls U plus or minus, V plus or minus. And this is a completely different thing. We can just call this length. Because a normal, and let's just say this here is our normal, coming off of our plane, usually it's in the center, so let's just put it in the center of our plane. There you go. Right. This bit here is usually oh my god, this maybe I'm better off using Photoshop for this because it won't do this. Okay, so this bit here is usually the length. And why is this important? Well, basically because of normalization. A normal whatever always has a length of 1. Okay, so this is a thing about normals. It is a requirement for a normal to be called a normal. When you change the length using B here, you affect how much the intensity these two will have. So these directly affect the intensity of, you know, the other two values and which direction it's going. So what this ends up doing, and a U plus or minus, it ends up being 1 to -1. And the same thing here. Okay. So when we have our red, green, blue of, and let's just use a different color here so we can, visualize this. When we have, woohoo, come on, color, 1, 1, oh my god, 1, 1, and 0, okay. What this is going to end up doing is, so positive and positive, right? This is going to lay it flat in that direction. So it'll go along the surface of the normal instead. This will basically turn the entire normal, the basic normal of your surface by 90 degrees. So essentially the max you can get with this is supposed to be 90 degrees, giving you 180 degrees of rotation. That is how normals usually work and what's going on there. And this is why you always see everything with that very bright color, which is normally 0.5. Well, it's actually normally 0, 0, 1. And this equals 127, 127, 255 as a color value. So that's, and I probably should have used a different color for that, but that's basically what's happening with a normal map. So knowing that, we know this 127 and we know this 255, where this is 1 and this is supposed to be 0.5. The way Unity is calculating this is simply 127 over 255. This is a problem because when you do that, you get 127 over 255, you get that, which is clearly not 0.5. It's a little off of 0.5 there. And that very small amount is what causes something with no normals, normally, like this hair, right? To even if when neutral normals are defined, because that's what this, when no texture is here, right? That's what that is neutral normals. That none basically ends up equaling this. Okay, the 127, 127, 255. And when we start to scale it, you can see the FPE kick in, because what's actually happening is the normal is moving by, well, let's copy this, 0.5 minus that. Yeah, so it's moving by, and let's use Notepad for this, right? Oh, actually, we can write it in here. So it basically ends up moving by this. And that is the problem. So what we need to do, actually, if I want to fix this, if I even want to bother to fix this, is to do it with integers. Basically, get an integer value, an int3 of the normal, instead of a float3, and then convert the int3 to float manually, because then 127, we would subtract 127 from it, and then we'd have 0. So again, it's a matter of Unity doing things in the wrong order of operations again. And that is how we get these things, how we get these problems in Unity. Hopefully they fix that someday in the future, I guess. And it's happening in URP, because this method, this unpack normal scale, which is funny because in standard rendering, it's unpack scale normal. Okay, so this is standard pipeline. And this one is URP. And both of them suffer that same problem, where they calculate it using straight to float values, which means that float value we get is this. Well, actually, it would be, sorry, this for our normal adjustment. This becomes our normal mapped normal adjustment. And so when you put this number into this, well, bad juju happens. So, I mean, let's prove it, right? We have this, we know this is here, right? We can do here, tangent, well, okay, let's just paste that there first. Tangent space normal. We can just set it here, really, to that. Okay. And then go over to our window, where the hair was all wonky. Oh, actually, it's going the other direction, isn't it? So if I comment it out, or is it the same? Actually, it looks like it's probably the same. Oh no, it does shift a little bit. Okay, so there's that, right? Actually, somehow it's worse. I don't know what they're doing, but the FPE is worse. I don't know what they're doing. They made it worse somehow. Or maybe it is positive. Let's try positive numbers. Okay, and there's positive numbers. Let's comment it out. We'll compare it to the other. Yeah, it looks actually like it's more because of positive number. Oh no, it is. No, it is. It's actually worse. I don't know what they're doing then, because this is the floating point precision error. From at least it being 127 or incorrectly calculated. But somehow they've managed to make it worse And I don't know how. Maybe it's 128. I don't know. Maybe they add one and do over 128. I don't know. I would like to see what that source code is, honestly. But yeah. Whatever. So yeah, we had, got normals in there. Of course, rendering. Added the basic rendering stuff that I usually add to my shader. That gives you a little more control over the pipeline stuff. You can choose what kind of pass it is, and this actually sets the keywords. It's not even a keyword. It's a flag. A little smart thing I did, I guess. Which it basically these tags, right? Normally there's a render type opaque. Actually, we can remove that. Yeah, let's go ahead and remove that entirely, because that is getting defined by this. This forces it to the proper tag. And for some reason it was already on transparency. But let's not have it on transparency. Let's should be on geometry and opaque. Whee! Okay, so opaque. This is where maybe I should have it, like, remember the state of those. But opaque one, okay. Okay. So, yeah. Actually, maybe the reason it's not, and I'm thinking out loud already, getting sidetracked. Shader. Oh, that's the other shader. You want editor of this one? That one, okay. And I don't know. Let's just fix this right away because it's bugging me. The feature, yeah. Static. I wonder if that happens because these are not set to static like they should be. Okay, render section, static bool, static bool, static bool, static bool. Okay, create emission toggle. This should actually be in the, base texture and color, maybe? Where does it have it on URB? That's a good thing to ask, huh? Advanced options, probably. Nope. Detail inputs. It has a mask, has a base map, has a normal map. Surface inputs, which is the base thingy for me. So yeah, base, metallic, normal, height, occlusion, and emission. Yep, okay. So it does belong in emission. But create emission toggle. That comes from my shader. And now we can get into actually doing new stuff, but let's get into, like, fix this shaders, because I was working on adding this feature stuff into it, which would be the next thing that I was going to work on. All the normal stuff is whatever. Yeah, so for now, that's in there, but I don't know. Well, no, that's not in there. This is the end line, so we don't need that. Ramp support, we don't need ramp support. And then I guess, I don't know why there's a vertical here. We can get rid of the vertical. Or maybe actually that's why there's a vertical, because it isolates the feature map here. And then we can begin a new vertical. For what though? Reflection type, not needed. Ignore attenuation, definitely not needed. We're not doing that with this shader. Other, I don't even know what that is. Yeah, none of that's needed. This needs to go, like I said, into the base pass. So that completes that. So back to base options. So there we go. We can go ahead and put that in there. But we need that create emission toggle, which is its own thing here. And that goes down in. This is create toggle properties. All that. It goes in here. It's one of these guys. Okay, there we go. Looks like it actually did just fine. Or whee! Oh, what's going on here? Contains string. I think this is because we're missing system.link. Yep, there we go. Okay. What kind of thing is this? Is it a numeral, generic numeral? Why am I using link when I could be using system.collections.generic then? Oh, because it's not. Never mind. Okay. Whee! Okay, so yeah, this is the feature map, what we're going to be doing with it. I need to change up the options of that because that is changing. Should go red, green, blue, alpha. Let's see, there, I'm going to actually pull this up to face, to whatever. So feature options, or map features options, there we go. This is, okay, what defines those channels or what they're supposed to be. So the feature map options, feature map creator. This is what we want to edit because we want to make sure these two reflect each other. So the first channel is supposed to be reflection. Reflection / metallic texture. And this is, and it's supposed to be all black and white. These textures need to be grayscale, blah, blah, blah. Yeah, okay. So reflection texture, red. So we know what channel it's going to be dumped into. The smoothness texture, which is going to be the blue channel. Oh, green channel, my bad. And then the reflection texture, that's also wrong because it's not reflection. What it's actually going to be is the clear coat texture. So blue. And the final one is actually going to end up being the specular. Because we're doing things a little different here than the other one. It'll be the alpha channel. The height map will be its own thing, separated eventually. I do want to do height maps for this texture and for this game, but I want it to be separated from this process flow. I might do more shader packing like this. Basically for any kind of masks, I might just make a general mask creator, which will combine like a detail mask. So yeah, the detail mask, the emission mask, and let's write this down so I don't forget, actually. Also need a creator for mass, detail, emission, and what was the other one? Ambient occlusion is a mask, actually. Other things usually have a mask on them that should have a mask too. For this, I want to look actually at my shader, but that's a little difficult here to do because, yeah. it doesn't load in this editor, or in this version of Unity for some reason. Looking at this though, we have normal map. Okay, that's already in there. Height map is not a mask. Occlusion map is, yeah, kind of a mask. Do. Yeah, the detail mask, the emission mask. What other masks are there usually? Brain. Let's look at my shader then from a different perspective. This one, okay. So in this perspective, we have all of our variables, which is kind of a chaos. The reason I wanted the reason for packing these textures is to lower the number of samplers used, because the more you only get a limited number of samplers that you can access, and we don't need to waste an entire sample just for a mask. It's unnecessary. Light map overwriting. I don't think we need to do that. So yeah, normal, feature, detail mask, glow mask. And I don't think we're going to do toon shading. So I think in this particular case, maybe we can actually get away, again, because there's already, we can put the height mapping in here. We'll call it height mapping. So we'll make a second one that also handles, that. Yeah. Yeah, okay. And make feature texture, samples all those. Yep. Okay. Oh, here's a problem though. They're not labeled right. Spec text, smooth text. This is a little off. So let's correct these orders. Like, that's not even in there anymore. I wonder if I can just texture 2D, yeah. For we'll call it feature text equals new texture 2D 4. And derp. And yeah, this would be that. Feature text. Okay. And this would actually then just be 0, 0, 1, source 1, 2, and voila. There we go, right? Yeah. And of course that breaks this. But of course, just to make sure it gets in the right places. 1, 2, and 3 because it's RGBA. I mean, that tells us the right thing anyways. And of course would be feature. And actually what we can do here is texture 2D. The problem, yeah, those are gonna have, I could make those reusable, but then like, hey Pumpkin, you're a dork. She hasn't said anything all night, so I feel like, she should be saying something.
Oh, sorry about that. I think I bumped into something. Again. My lack of vision is really a real pumpkin killer, haha.
Actually, we're just going to abstract this because it's going to be like that, and the output text is going to actually end up like this. Which is odd because why is it now? Oh, I see. I create an output text here already. What was it before? Feature text? Result text. Weird. Yeah, I see. This is another thing here too, that these all actually rely on the colors all being the same length. If any one of them are the wrong length, it will blow up and die. What we want to do though too is if the color doesn't exist, then it should be 0. So we're gonna do color like this. If input text. Oh wait, I get value. Huh, I see. Never mind. Let's get value, so it should return 0 if it's not the right size. But the colors here, you get pixels from the output texture. It's okay, yeah, it's just gonna assume you create the output texture, but then it's gonna copy everything. This does still expect you to have the same resolution though. I don't know. I guess whatever. I don't care. But now we have this abstracted to where it's between two different textures. Interesting. What is get? Why is it get value? Oh, get value here, and then otherwise return 1. Yeah, it makes sense. Where's text used here? Oh, I see. I do abstract this to some degree. So yeah, texture, 2D, output text. Okay, just like that. And then so now these actually want output text sent to it. And there we go. Okay, so make feature texture. This actually then would be feature. Actually, it should just be make texture now instead of make feature texture, because we want to reuse this. Right, so then that becomes feature text and feature text, plural. All right, so now we also take the same whole thing again. Might as well do it now, get it out of the way. We can call this mask group. And we'll call this, of course, mask text and mask text. All right, so there we go. And then we have then the mask text and the mask text, plural there. And then we can rename these to what they are. Detail. Mask. Emission mask. Ambient occlusion mask. Well, it's just ambient occlusion. It's pretty much a mask, but it's its own kind of special mask. And the same thing with height mapping. It's also a type of mask. And then there we go. Apply to mask texture. Okay, so you know, yeah, mask text creator. We can put that next to the feature map creator. Okay, and yeah, different. Wee. Oh, mask group. Yeah, no, that mask group, but it's opening the wrong here. Boop, boop, boop. There we go. And of course, naming. Oh, something happened there in light enhancements. This actually should be feature mapping. But what did it error out on? Oh, probably things that don't exist yet on the shader, of course. All right, so let's add those, at least in the shader definition portion. So we have our stuff here. What we want to add is the feature texture and in this case mask texture. So actually feature options, right? Let's go back up here and then also have mask options. specular code. Specular. Okay, in this particular case, it becomes the same thing of what we wrote. Right when I thought I could get away from doing that, here I have to still come back here so I can see, yeah, what I wrote in here. So this one becomes detail mask. And then of course detail mask. Okay, and this one becomes emission mask. And this becomes ambient occlusion. And this one is going to be height. Yep. And these are all scalars, by the way. Yeah, this should be 0 to 1 scalars. And then, of course, this would then be the mask group. Where does it contain a mask group already? Mask creator. And yeah, and then we can remove that. Alrighty, so there we go. Yep. I still don't know why we have this reflect type here. I don't think we need it anymore. I think we can go ahead and get rid of that. Okay, so we have feature mapping, and that doesn't work, and yeah, that doesn't work. Oh yeah, these are things that don't exist. And this is actually supposed to be mass controls, we'll call it. No, mass configuration. Oh, we'll just call it mass. And feature options should actually just be features. There we go. And yeah, let's get those variables in. So we have the feature texture, and we know that it's going to have those other variables. Feature options. Actually, we can start with, oh, this is mass text. Okay. I think we should probably just call it features text for the shader. Yeah, we'll figure that other stuff out in a bit. So mass, of course, then we need oof. It'd probably be easier to do like this. And default value should always be 1 on these. So yeah, feature, or mask. Okay, detail mask. Detail mask. And then of course 4 different ones with emission, ambient occlusion, and height map. The thing is, I don't know. Some of these cases it may be a thing to go over 1, but I'm not really sure if I want to allow that yet. And if I do see a need for it, we can always change that. But yes, let's get the base functionalities of these things in first. And now, of course, we have. Oh, what time is it anyway? 7:30. Okay. Reflectiveness, smoothness, clear coat, specular. And the reason, yeah, for features is these all belong to reflections. Like the clear coat is a reflective property, smoothness is a reflective property, specular is a reflective property. Specular is an odd one where it also includes lighting. So we're going to be doing, like, going over the lights again, another pass over them, just to get light position and color to do the specular process in this. And this will all probably be one actual function. This will all belong in the reflection stuff. But this stuff is odd because each one of these get used in different approaches through the the whole process. So that'll get interesting in the way we use them. Like, yeah, I'm not going to create a mass.hlsl here for those. And again, to it so you can see it. But yeah, this little side bit, I'm not going to create a mass.hlsl for it. But what we do need to do though is, just as with those other samplers, we need to get them defined and usable by the the whole shader, which is done somewhere in this code. Light pass, globals. Yes, globals. So yeah, we already have our main text and normal text, but now we need the other two textures we just created. In this case, mass text. So you can just take that and put it there and put it there. And then detail mass. Oh, no, not yet. Features mass. All right, but then there's another one that needs to happen here. With these, there needs to be another 2. That is the detail text and detail normal text. So where we have these 2, down here we need detail text And of course, detail normal map. So there we go. We can then put that there and there. Detail text, same deal. And of course, we're going to want to set up normals just the same as we did for our regular normals. So the detail normal also needs to be processed in that way with its own things. So we might as well set up in the vert these guys here. We have UVN. We're also going to want to float to UV detail N. And then we're going to want a detail normal. I mean, shoot, since I'm already doing details, I might as well just do details. Yeah. It's an easy one to get out of the way and should just be done. Going into the exploration editor. We have our base options. Essentially, it's all of our surfaces, so we might as well just all of our surface stuff. So we might as well just do it in here. Emissive boost, yeah, that's gonna have to get moved too because it's gonna move somewhere else. Well, maybe not. No, that'll probably be fine where it is. But yeah, detail text. Detail text. Okay, so we're gonna need a detail color even. So let's go ahead and add detail color to the inputs, exploration shader here, detail text color. Okay, yeah. So we have, main text and then color. Okay, yeah, and then we would just want to take that out. Actually, in both of those. Detail normal scale and then detail color. And then, of course, detail color, detail normal scale. Oh, wait, so back to the shader editor. We can probably put that over there. So yeah, detail normal, or color. So detail color. Let's put that in there. Oh, it already is. Okay. And then detail normals. Yeah, normal texture. So detail normals like that. And then detail normal texture. And then of course, yeah, detail normal scale. And for some reason we got stuff in there that shouldn't be in there. So yeah, detail. Oh, that's why, because this is supposed to be detail text. And it should also read, of course, detail texture. This is an interesting one because, yeah, the mask is going to be either based on alpha, or the detail map, our detail mask. Oh, that's interesting. What made mask break just now? Yeah, finishing this part of it, I guess. So yeah, mass text, mass. That should be working. Let's take a look at it, I guess, in the mass option. Mass options, mass group. There is mass group and mask options. Mass, okay, so it's looking for mass text. Mass girl text. There was no shader compile issue, was there? Why am I just clicking aimlessly? Anyways, there we go. An implicit truncation of vector type. That's something we don't want to happen, really. Which is this, basically. So this should be RGB, but then also not RGB. Actually, the truncation is happening there, not here. And again, we have it there, where again we use base color, but we didn't take just RGB out of the base color. Okay, and then we have it one more time. Which I don't know what is. No, because yeah, this should be XYZ, I think. There we go. And of course, vert is not completely initialized. This is happening because we just introduced the new normal, which needs to be DN and detail normal text. Oh, we still have something not initialized. Okay, what did we add? Okay, so position CS, okay, that, normal, detail normal. So regular normal object space, detail normal object space. Right. O dot detail normal object space equals float for v dot, yeah, normal 1. Okay, and so when we actually go to calculate detail normals, yeah, we can do that in a second. Let's just make sure, again, that our editor is not having any cutouts, which it is. It's quitting out here. That's also strange because it's, oh, there goes features blowing up. Feature text. Cannot find material property underscore feature text. Normal text, detail text, mass text, features text. Okay, that's the problem. Okay, so features is rendering twice. Interesting. Looks like that's what's causing the mass to not work. And there's Y. Wee. Okay, so features, mass. There we go. No, actually, did we fix that problem of it closing between switching? Oh, that's the other one. We want to go to exploration. Oh, okay. It stays open now. Good. Sanity is returned. Okay, but yeah, mass, and you see the okay, blah 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 blah. Base texture, you get your detail. Detail mask is just basically multiplying into the alpha of the detail texture. The alpha of the detail texture is already a mask in itself, but whatever. That I guess is like the extra fallback for if you don't have a mask already. And of course, yeah, detail color. So yeah, let's finish getting those detail normals in. We do normals. We have our world space normals, right? Yeah, pretty typical. We want to do this same thing. Let's see, binormal is based off of, yeah, a normal. So we actually need to have it specify we'll just do this, and well, obviously binormal then is going to have its own thing, and that is in the vert. Actually, the shared globals. So we have normal, and tangent. Oh, it's in the process. Tangent. I think tangent is consistent here. It's passed in as part of the normal. And that's why we don't, we don't have more. Right. Oh, it's the base normal and tangent. Okay. Yeah, this is the normal map normal. Post normal essentially. And why is it in varings if we don't use it in varings? What happens in vert with that? Detail normal OS. We're splitting it between the two, the regular normal into each one of those. We need to look in my shader here specifically for that normal object space. Do I use it for anything? Object world and process. I don't think we need a detail normal OS here. What we need is a yeah, let's go back to varings and make sure that that is not in there. This is just passing regular normal over, which is just the base normals. We don't want any of the post normal stuff in here. And let's put these two together since they're related to each other, normal and tangent. But in process is where things actually get interesting. In process here, we actually need normal WS normal map. Wait, why is it normal map? Oh, because that's where I'm sampling it in to. Okay, yeah. And that is the... Does tangent and world space ever get manipulated in any way? I don't think tangent has ever changed. Yeah, it's derived off of the base tangent, so it's never changed in any way, and it doesn't need... This is like... This is immutable. It gets created, but it never gets changed to anything. So that's where we need these to be detail. Okay. And so now when we create normal world space, we do the same thing with detail normal world space, but we use... No, actually same thing. But it's going to change up in how... Huh. Yeah, actually we end up with a different... We end up with something... Oh, hey. Yeah, thank you, Chris. Thanks very much. Appreciate it. Sorry, I just now noticed. I don't know why the bot didn't tell me that somebody messaged, but whatever. Brain gober. I just realized now what's going to happen here is one set of normals is gonna, like, the detail normal is gonna have to be used when the normal isn't used for lighting, and it needs to be based on the detail mask value. So a detail mask value needs to be created in process to go with it. So float detail mask. And right now, let's just make it 1, just so it is defined in this process. Actually 0. But this needs to get computed based on the detail texture alpha with that detail, which we'll do when we apply the detail. And then, normals will get calculated with this. So when we have this detail mask, it's a lerp between the regular normal and the detail normal. Okay, so let's just set that up, I guess. Detail normal, and now our normal map here. So then we do detail normal map. Whee! Detail normal text. Is it title? Yeah, I'm pretty certain it's title case like that. And of course, detail normal text and i.uvdn. Why is it i.uvdn? Oh, because of it. Yeah, never mind. Is that getting created? Varyings. Yeah, it is. Oh, wait, well, I mean, yeah, is it getting actually created? I don't want to just double check on that one. Globals. UVDN, but it's in vert. UVDN. Okay, it is getting created from the detail normal texture. Okay. Back to process. So now, we get the detail regular normals processed with our yeah, generic or normal. We basically set the default, the end result, base of the end result for this here. So yeah, normal map as detail normal map. Tangent world space, this is again a constant. Not to be confused and mixed in with the others. Okay. So detail normal map, detail by normal is our binormal in here normally. Binormal is not listed in here, even though we should have process binormal equals just 0 and process dot detail, just to have them like, you know, define as like our varyings. There we go. So now though that gets calculated here, and we do the same thing where we take our, which is funny because our normal world space is already, but whatever. We create our binormal. There we go. Tangent. It stays. That stays. That stays. All that is pretty much the same. I wonder if we should save some compute time and do a float. What the fuck even is this? World transform parameters. I mean, what would I call this in a combination? It's the tangent world space W, which is its scale. And there, that way it's not doing it twice. And why is there... Right. So there we go. We do a cross product of those two times scale to get the binormals for each. Of course, this is supposed to be detail binormal. All right, so now that we have the detail binormal as well as our regular binormal, yeah, we create binormals, just put them in process. We now then have our normal map. Yep, a detailed normal map. And then we do this again. But now it's the detail normal world space. Yeah, process dot detail normal map. And then, yeah, that normal scale. Except this would be detail normal scale. Oop. And of course, we need to make sure it's getting carried into here. Okay, so we got our, yeah, tangent. And then we do our math on that tangent, and again, do the math on the tangent. And this is using, okay, tangent world space, that stays the same. This becomes detail normal world space. This becomes our, yeah, detail binormal. Okay, and does it blend? Womp womp. Okay, what do we do wrong here? Create binormal, undeclared identifier. Oh, because binormals. And actually, we just do void. We're not returning anything. Except we are. We actually wanted to return just... Oh, because I know it's going to probably do it by reference. But in some cases where it breaks that behavior, it's just good to just have it returned so the compiler knows how to properly return it. The compiler can sometimes get dumb about it, basically, which is why we return it anyways. Okay, so yeah, that's our behavior. normal's out of the way for that. Now we can actually go back to our main fragmentation shader, where we see our base color is being added. This is where things get interesting with each other. Yeah, this is where we probably want to... This is set process, actually. Sorry, it's in frag here. So yeah, we set our process. But then now we have our details, so now we need to say set details. Yeah, is the only proper thing to do here. The process equals, and that's the detail layer should be the next step after you know, our base color. All right, so in our details, process, that details, and then of course our process, and return process, just to make sure it's getting passed along. Now we're messing directly with the base color, so process that base color equals, in this case, we never sampled our mass, did we? In the process here. So in the process of here, we're going to need float for mass and float for features. All right, those are mass and features values. Simple enough as the others here. And actually, it looks like we need, of course, besides base color, we need float for detail color. And, well, detail. We'll just call it detail and detail color. Shoot, so let's get that out of the way here with, oh, I guess we don't need detail color. We can just call it, yeah, then we can just call it detail color. We can, yeah, do detail color, and then we do detail text, of course, times the detail color. So there we go. Boop. Of course, things aren't complete, so it's kind of like, hey, what are you doing? But detail color never got defined. Okay, so what happened there? Expiration shader detail color is defined right here. So what is, oh, because in process then we don't have, yeah, float for detail color. Okay, so there's float 3 to float 4. Incomplete. I mean, what is it? Okay, let's just go straight to it. What are we talking about here? Okay, so detail color. Why is detail color a problem? And then it's not, so I don't float for detail color. Okay, so yeah, sampler, detail text, blah, blah, blah. Okay, here we go. Now unidentified, so that means actually what we have here is we forgot to put it in this. So hash include, yeah, details, HLSL. Blah, blah, blah. Okay. Wait, what is it complaining about though? Unidentified, okay. Did I accidentally include it before process? And yes, I did. Process should always go first after globals. There we go. Whee! Okay, so there's all the stuff set up for our details. Now we need to actually, well, not entirely actually. We still don't have the mask in there. So let's go ahead and get that in there too. Do. Okay, this is still Skull shader, not my shader. So like not this shader. Okay, so detail color. We now also need then after all this, we need process dot mass sample. Okay, this is the mass text. Okay, and mass. There you go. Yeah, that UV is going to be interesting because this is actually UV mass. So yeah, we have a problem in that we need to adjust, I think. And this one's going to be UVF. And actually, that's where we also have a problem here. This needs to be UVD, which probably doesn't exist. And our detail normal map, yeah, we already have I.UVDN. So let's keep that up there. What did I put in for globals? UV normal, light map, DN. What we don't have is float to UV mask and float to UVD or F. Actually, that should be 6 and this should be 5. This should have been 4 and float to UVD. There we go. Mask and features. Mask and features. And of course, this one is features. And we don't want detail color to be multiplied on that. That would be bad. Okay, so that means we have our varyings aren't complete now. So back to vert, we actually need O dot UV mask in transform text V dot UV mass. Oh, this is just mass text. Okay. And then O dot UV F equals transform text V dot UV and then of course features text. And there we go. So yeah, normal detail. Oh, we're missing detail. So yeah, UVD, and that is detail. Does it make a detail or details? I don't remember now. Let's make sure of that. It should be up here actually. Detail text. Okay. Detail normal, detail text, normal texture, blah blah blah. It's 1, 2, 3, 4, 5, 6 different. And I have 7 because of light maps, right? Light maps are their own internal sampling. That's always reserved at texture coordinate 1 as an input. But yeah, we're expanding UV because of the UV of the surface to all the others, but the different UVs there are going to change based on the transform text details of each one of these textures as they get passed in. And voila! Okay, so details. Well, actually, make sure it's all still reflected properly and yeah, process UVD on UV. Okay, mask features. Okay, so we have that all populated. This is wrong. I'm glad I looked at that. Detail text is what that should have been. Okay, so there we go. Detail text and color are there. And yeah, so now we need to populate in features first our detail mask. I don't know why that's at the top. Well, whatever. But where's... Okay, so this should have been actually then put down there with it. Just for the sake of ordering it in a way that I can keep track of where stuff are, and I can even put in a little details section here. And then, of course, mask and features. Okay, so I should probably leave a note here too, what these mean. So red r equals of mass. Going back to the shader editor. Whoop. So yeah, here's our mass, and why does this say feature? This should be mass texture. And this should just say features texture. Okay, so mass texture r equals detail mass dot g equals emission. Mass dot b equals AO. And mass dot alpha equals height map, which that's going to be a tough one to set up. Okay, and then likewise features this is reflectiveness, metallic, smoothness, clear coat, and specular. And actually, I did all this for no reason. Or maybe we want to contain and keep them in here. I think we want to keep them in here. Because what we're going to want to do then is in our fragmentation shader, and maybe even part of our process setup. Yeah, that's part of our process setup. We're going to actually do mass.r times equals, and this should be our multipliers. So when we go to our exploration shader, we should have those things already, like, detail mask, right? So detail mask, mass.g times equals emissive mask. I don't know, maybe I should just make these all, break them out. I think, actually, I should probably just break these out. Float detail mask, float emission. Maybe easier to work with if I just break them out. Float ambient occlusion, float height map. All right. And then features float, reflectiveness, float, smoothness, float, clear coat, float, specular, and then we can get rid of that part. So what we're going to do instead is when we actually sample them here, which we already have this transformed, what a stuff. We're actually just going to take, we're just going to do float 4 mass, and float 4 features, and just apply it here directly to it. So process dot, what is it, detail mask, or equals mass.r times detail mask, and there you have it. That's what it is. And then of course process dot emission mask equals mass.g times emission mask. So there you go. And even up here, let's just go ahead and start getting them also defined. There's 8 items in total. Which is, detail mask, emission mask, ambient occlusion, height map, reflectiveness, smoothness, clear coat, and specular. And why are these all ones? I don't know. These should actually have default values of 0. We don't want to use any of those unless, we have to. But the mask, on the other hand, need the opposite of a default value of 1. Except height map. Well, no, I mean, height map actually has the same too, because 1 would be the surface. Height map would dig in. The same defaults values, essentially. So there we go. And now we fill in the blank. So emission mass, ambient occlusion. This, of course, is dot ambient occlusion. Process dot height equals mass dot a times height map. There we go. And there's feature or mass. And now process dot reflectiveness equals mass dot r times reflectiveness. Process dot smoothness equals mass dot r times smoothness. And each one of these, oh, see, this is already fucked. This should be a default value of white, because what we want is these to be 1, and then you can optionally turn these on individually to max value, which is white. Same here, we want this to be max value of white, where 1 Well, if there's no if there's no detail mask, it's just going to be alpha driven. There should be 1. And an emission mask, of course, we want all the emission to come through, if not define, which is also a little odd. We might actually want this one to be, no, because an ambient occlusion is a problem, where ambient occlusion is the brightness of it. Emission mask should actually be 0, because what it's going to do is the emission color is going to get thrown into emission mask, which guess what's not in here? We don't have a emission color. By default white, but this should be an HDR color. Speaking of which, though, all of our colors on here should be HDR, and that's actually the first problem I have here. All the color inputs should have been set to HDR on in. Because we are using an HDR workflow, just not traditional. We're not using HDR, you know, the HDRP. Unexpected undefined at 15. Oh. Yeah. Huh? Redefinition of detail mask. Process. Yeah? Where did I define it already? Well, I haven't even finished this bit, so let's do that first. Smoothness, okay. Process dot clear coat equals mass dot G. No, this is G. B times clear coat. There we go. Process dot specular equals mass dot A times specular. And there we are. And now we still have redefinition of detail mask. So it is a problem. That. Yeah, why is that there? Nobody knows. I know. Because I'm silly and totally forgot that it was going to be its own individual variable in the first place. And that now that we have that, actually, we can set this mask. We can actually set this up immediately here with detail position. Now process dot detail color dot A. And there we go. That's the detail mask. And then from there, we can use that as a baseline thing to test with. We can actually go to our normals when configuring and setting up our normals here. We have detail normal space and normal space. We can actually drop the detail normal space now because we won't need it. So in process, detail normal space, we'll need the map, but we won't need that. And we won't need detail by normal. This is where we can actually, yeah, now we have this, which is going to cause a problem with this. The binormal, this is interesting because, yeah, what is a binormal flow for? Process. Binormal is only ever used for that anyway, so we could probably even take it out of this. Get rid of the binormal being carried around everywhere. It's only like a one-off thing anyways. So now, what was it though? It was a flow 3. We switch this to flow 3, and we say float 3 binormal equals get by, or create binormal again. From process, where we have pass in process dot normal. Okay, so we're actually going to want float 4 normal, and then we do process dot normal ws. Wrong. We don't even need to do that. I think, yeah, these are going to be the same. So we can go back to what it originally was, this whole formula, where we multiplied that at the bottom of it. And actually, yeah, that's the return. So there we go. It is just normal. We can create the binormal here. We keep the binormal here. We have, but now where are we getting the, oh yeah, the detail normal map instead. So we just, yeah, create the tangent there, create a tangent here. We actually want to make this then instead. Float 3, output normal, or output, base normal equals, and then float 3, detail normal, yep, okay, that's a thing. And then we process dot normal world space dot xyz equals lerp base normal and detail normal by process dot detail mask. And there you go. We've handled how the normal transitions from the base to the detail between its subset of normals it has itself. Okay, so we have a hiccup in there somewhere. Float 3 process. Huh? Huh? Where does it do? Where do I end up doing a float 3 process? Oh, here. Yeah. Okay. Invalid subscript by normal. Yeah, this is just the binormal. It's all the same. And this is also just the normal WS. All the same again. It's basically the normal coming in world space value, and the tangent coming in world space value. So yeah, that's why they don't really need to be changed. Our calculated tangent normal, or base normal and detail normal, as a final normal are what matters here, and driven by its normal maps. And then there we go. Except, where'd they go? We have no detail texture. This is the problem of doing yeah, the detail is white. The detail texture should default completely black. There we go. Yep. And yeah, that handles the transition of the detail. Okay, so we can now apply the detail. It would be nice to have something to experiment with, maybe, but I'm gonna go with my gut on this one and knowing how it's set up, and it should just work. If we have problems with it, we can always revisit it and fix it. set details. So in details, we just basically take process.baseColor equals lerp of process.baseColor and process.detailColor by, and you know what's funny is I don't even think we even need to set details at this point because it's all done in a detail mask. Yeah, this is all done. I don't think we need a sub function class like file for this. So in the frag, we can just literally put that in there. And we can get rid of details. Boink. Light pass. Lighting normals. Nope. Shoot. Reflections, vert, normals, light pass, light, inline, globals. Brain. Where was this thing created at? That we just removed. Yeah. Includes in lighting. No. Light pass. Light pass. Light pass. There we go. Okay. Okay, so detail texture and color, okay, detail normal, and it's, normal scale. Yeah, and I mean, we can just take the normal map, honestly, and put it on there. And we can just maybe say white pixel and see if, yep, that carries between the two. Except notice it's more intense. And then, of course, if we do that, yeah, we can see it transition between the two sets of normals. Alrighty, but now, does it handle tiling correctly? It looks like no, something happened there. Oh wait, that's just the... Wait, why is the white pixel mask set as a normal map anyways? Okay, yeah, that was goofy. Shave. Okay, so back to this. Actually, we want to just set that to its normal texture. And then actually, yeah, we can see that it scales, definitely. So now let's remove that back to just being white. We use that white pixel. White pixel. Right, and then let's, yep, details. Okay, so all those work. All is good. And of course, if we set it to none, we should just see what it's supposed to be without details. There we go. Whee! So yeah, I guess next feature on that list, we got details all out of the way. I wanted to work in reflections, but I got into that little sidetracking, which is not bad. It needed to be done. It's done and out of the way. We now have a detail layer. Oh, we didn't really test. We could have tested this actually from that. So let's actually give that a try again. So normal map. We'll put the normal map in here and white pixel. This other override here with the mask. This should be white, of course. So it should. Okay, and now if we have a black pixel, which we don't, So, okay, we got white pixel mask. Let's do that, right? Open that up in Photoshop. Open with a Photoshop. Alright, so let's turn this one into a black pixel. Boop. And then save as. Yeah, black pixel mask. Always make them slightly bigger than a pixel because, you know, I just have mip mapping and other things in case things, you know, to test bleed and make sure it's not getting compressed wrong either, because compression gets kind of weird when it's only like 1 or 2 pixels, or 1 to 4 pixels. So yeah, let's put black in there, which makes it none, just as expected. So we get no details because this is 0. So fully masked, as it should be. And then of course white means it's not masked. Whee! And then of course none, the default, means yeah, not masked, just letting all through. Okay. The detail map is an important thing in a lot of modern gaming, by the way. We'll probably use it in this game. I'm not really sure. I know we'll definitely use it for some tiled areas. It's hard to control as a separate entity from art. Like if we're actually like putting it on a piece of art, you know, an object or something in the world, because it can't. I mean, it would have to be its own layer of UV maps, even UV coordinates that come in. So it'd have to be like another entire UV channel off the geometry, if done in Blender. So that's probably something we would have to figure out if we end up doing detail mapping at a geometric level. But by default, it just uses the shared base UVs as, you know, the mesh itself. But the kind of things that it usually gets used for is, like, say we have you know, this face here, and we wanted to give the face some you know, kind of like a freckly detail, some pores essentially, and just to, I guess, simulate that so you get an idea. We can take we can make a pore map, honestly, pretty simply. We just do new in here. We can make it very small. We can just make it a 64 by 64 pixel. And then we do filter, noise. We just add some noise, some simple basic. We can give it a lot. Oh, we definitely want it to be monochromatic. Actually, it should be 100%, I think. Maybe not. Okay, maybe more like 25. Okay, so we'll do that. And then we, in levels, image, adjustment levels, we can see that there's a lot of white in it. We want to basically bring that down. And now go back in. See, those are now all like that. We need it to be sharper towards the black end of things. So we bring, yeah, the bottom end up. Now we get more of that. And we can pull this tighter to the front. As long as we get nice, well, blackheads in there. There you go, bam. And then we can call this, and actually, yeah, it's a color multiplier, so. The problem is, yeah, we're not exactly multiplying over the yeah, so we'll want to actually create alpha on this by doing a little trick. And then we do that. And we duplicate this, of course. I don't know why I even created a new layer. Delete this layer. Delete this layer. Then we say layer, new layer mask. We want it to be default reveal all gas. Select into it, paste this in there. Image, adjust, invert the colors on it. And now what we get is blackheads. And we can make them more skin colored, I suppose, by image adjustment levels again, and messing specifically with like the red channel. There, now we get more of a skin color. Okay, so now we have our pores. Layer. Nope, we don't want to flatten it. Save. Okay, so let's go into where that artwork is. Sure, close enough. That is not where we want to be though. Testing assets, and it's that texture. We'll call it PNG face details. And even more interesting, we can take this. No, we don't need normals on it. I was gonna put normals on it, but I was like, yeah, no. So we can then add that face details. And you see it already looks kind of odd because it's like not full. We do want alpha to be transparency. We do want it to repeat. Sure, trilinear, doesn't matter. Okay, making sure all that's in there is those details. But now we can actually tile it like crazy. So now we get actual like freckles on and pores on the character. And that's basically how detail maps are used. And we can even make it super fine. Yeah, and see, that's where we also want to detail mask too. Because we don't want it in the eyes, we don't want it in the eyebrows. It should just be on the face. So that would go into the detail mask portion of this. Separate of, what we just created. Or I could just, no, actually I can't, because then it would have to be the detail mask doing it aligned with this. But yeah, we can increase that even to that. Or even get like super fine. And there you go, now we got a face full of pores. And I guess, yeah, since we're already on this path, let's go ahead and create that mask. I just want to see what it would look like with a nice mask. So let's go ahead with the white, the face. Show and Explorer. Let's just grab that again, same way we did. If open, yep. And then of course we want the detail mask. We can just simply select that. Paint some white in there. And of course, new layer. Bring that down. And we make that all nice and black. And there it is. There's just simply our detail mask. Layer. Flatten image. Image mode. Grayscale. And then save as. In our little area. We call this the face detail mask. Okay, right? Bam, done. We can then close this. We don't need to save that. That's already been saved. And of course, we want to now create our mask. So that's where things get a little complicated when with the setup, because we do have to, like, you know, pack these. And I could actually just do it. Actually, yeah, why not? I'm just gonna do it because as much as I trust this thing to do its thing, it's faster for me to just open freaking Photoshop and a detail mask, face detail mask. We can just save as a mask. And then what we do is we go back to RGB color, and then in channels, we paint white to the channel. Actually, I already goofed that up. And there you go. And now the end result is, well, yeah, that. Okay, so we have a mask for our masks. And womp womp. There's already a problem though. Why is that teal and not blue? Oh, because it's, yeah, okay, it should be teal because that should be 0. Yeah, we have a problem. Boy, am I working on the face or not? I'm not working on the face, that's why. Okay. Yeah, okay. Now we have a face mask. Ah, there we go, beautiful. And yeah, see, now we're not on the eyes, not on the other stuff. We got a nice, straightforward face mask. And we get freckles. We get those. We get a higher resolution detail on the face for cheap and free. Well, not free, but for cheap. And that's how you would use it. But yeah, that's enough for tonight. That's pretty neat stuff, right? I don't know. I kind of want to be able to actually see these freckles more. There we go. 20 is fine because you have to be like super close and otherwise. But yeah, there we go. Yeah, we just have nice toon shading and nice feature mapping and stuff now. I'll get back to working on reflections tomorrow, which is originally trying to put in here. Yeah, I don't have mission yet done yet. I don't have ambient occlusion done yet. That was a cheap, easy one too. Ambient occlusion. And yeah, I don't have the height map done yet. That's gonna be the most complicated one, probably the last one done. And then of course, if I do lighting, it's gonna be reflections. That's gonna be this basically features. I should probably just change this from features to reflections because that's what it's become, or reflective features. Yeah. I'm gonna do that now before I forget, because that's basically what that features thing has become, is just reflective features. I just realized this is in a confusing state there. There we go. But yeah, reflective features. Reflective feature texture. I mean, that can be shorthanded. This is the heading is mainly what's important. And then features texture creator. So in this case, reflective features texture creator. There we go. And we have reflective features, and then yeah, our reflective features, of course, inside that section, and then of course a reflective features texture creator. And oh yeah, voila, done. Wow. And yeah, okay, that is now officially where I'm gonna call it. Oh wow, it's still 5 minutes technically left, but whatever. I started 5 minutes early, so I don't know. Is anyone even watching out of curiosity? I wonder. Yeah, but whatever. Yeah. I hope you find this later and can follow along with it and learn something. Again, if you are a subscriber and you have any suggestions for next week, get in to our subscriber channel and make sure to and I'm sorry, by subscriber I mean more like a Patreon subscriber. If you are a Patreon subscriber or supporter in any way, Discord Patreon even, Discord supporter in that case, get into that subscriber channel and start suggesting things to work on. And if something is relevant to this project, I will happily bring it up next time. And yeah, of course, the usual spew, like, and subscribe. And I'll see you next week. Hey, Pumpkin, say have a good night. Hey, Pumpkin, say have a good night. Did she fall asleep?
Meow meow. Thanks for tuning in, everyone.
Yeah,
Ow, whoops.
there she goes. Yeah, I think
Sorry
she fell
about
asleep
that.
for a bit.
Can't see a thing. Hee hee. Have a great night, and I'll catch you all on the flip side. Meow for now.